Assalamualaikum and a very good day. First and foremost, I would like to thank to MACE, the IFAC Malaysia, for invited me as one of the speaker for the Monday talk. Okay, uh, here I would like to share about one topic that which is one of my main research interest is a lake robot. Okay, let's take a look on the topic. So I'm actually want to talk about the lake robot in terms of principles, controls, and the trends. So at first, we go to the history of the lake robot and its evolutions. So as you can see here, the lake robot is actually uh, has been designed or has been attempted by the people to design and mimicking the life form creatures since 1700. But at that time, the technology of the energy is much more depending on the steam, and these lake robots are getting growth and getting getting advanced by the changes of the energy and actuation technology. Okay, as you can see there, they start doing the electronic based controls, and before that they have a oil based control, um, and and until today, this kind of robots is attempt to be in market. Okay, so that one I will tell you after this, by the end of the this talk. Okay, now why we so eager to design a lake robot? Okay, based on the Mark Ribert from the Boston Dynamics, which is currently is a founder for the Spot Mini robot. He said that that one in 1986. He said that only the half of the Earth landmass is accessible to existing wheel and track vehicles, whereas much larger fraction can be reached by animals on foot. So it means that with the wheel system have limited on accessibility if compared to the lake creatures. Okay, like animals with the foot. Okay, so that's why we need to design such kind robot or vehicle with the leg configuration, because the leg configuration can becoming the very adaptive system with the uneven or mountainous terrain. Okay, because the leg itself can become the adaptive suspensions to the body, so that this kind of robot can access more than the flat terrain. Okay, so so what's the key issue and motivations of the robot locomotion? So we go a bit back to the basic of the robot locomotions, because robot locomotion can be categorized including the wheel type of robots. Okay, so actually this kind of robot is trying to mimicking the life form creatures, like we can see here. They have a several type of motion that has been trying to be is mimicking by the inventor to design such robot locomotions. And leg robot are in the category of the running and jumping and walking type of mobile robots. Okay, so so when we go to the control system of the leg robots. So we are emphasized on the three most important issues in the leg robots design. So before we go to control, we need to know about the design of the robots, because the controls is depending on the design of the robots. Okay, the first thing is the stability issues that include the numbers and geometry of the contact points, which is the foot contact points, center of gravity, static and dynamic stability, inclination of the terrain, which is related to the environment and landscape factors issues. This environment and landscape, we need to identify the different of the surface structures and also the medium, either it for the land or for the sky, air, water, or maybe mix of it. Okay, like a mud, or the soft terrain, or the underwater with the very high tidal. Okay, so another point of core issue is the characteristic of the contact, which is the contact point, the size and the shape of the foot that we want to design. So what the size of the foot, because that one will affect the stability of the leg robot. And the angle of contact means that that related to the inclination of the terrain, and of course the friction, because when they move they have drag motions, and there will be a frictions. Okay, so in the robot designs and control, so I combine these two. The design can be listed from the problem of the joint movement, overall balance, present and future footholds of the foothold actions, means that the strategy of the walking, and reachability and reconfigurations, which is the target of the trajectory. And all these need to refer to the stability principles, and configuration means that the mechanism of the robot design. And then we can come up with the either for the motion control, locomotion planning, and perception. Okay, perception is actually is about the eye of the robots and the sense of the robots. Okay, that involve the sensors, vision system, and image processing. Okay, and all this solution, most of the inventor researchers has been further with the artificial intelligence technique, either with the AI algorithm or AI technique, or maybe the optimization techniques that currently is quite a very popular field of interest in the artificial intelligence. Okay. Okay, another thing that we need to consider is the configuration and mechanism of the leg that we want to choose. Okay, in the design they have several type of legs, which is majority are inspired from the leg creatures, like a sprawling type, mammals type, and another one is a C type. C type is a sliding and rigid sliding kind of leg, which is regularly apply with the R-Hex leg robots. And the robot is like a small dog with a short leg. And another one is a telescopic type, which is like inspired from the suspension systems, and it looks like a kind of a galloping walking style. And I found these kind of robot that use the telescopic type is on, I think, in some one of the university in China have create this kind of lake. All right. Um, in the lake control, they have they have several stage of control, which is the first one is lake motions, and another one is robot's legs overall waypoint motion. Okay, but for the most important in the leg robot is the leg motion, because the leg motion playing a main role to create the shape of the leg, the leg motion. For example, the bipedal robots, it has a motions like almost approaching the wheel motion, because when the distance between the between two legs getting smaller, so the polygon are approaching the wheel, which is from the with the shape of the polygon and becoming the almost rounding. Okay, it's different to the multi-legs robots, starting from the quadruped robots. Most of the leg motion are designed by facing, okay, by face, sorry. um, so then they have a swing phase, they have a grounding phase, and have a dragging phase. Okay, like this one is an example from the hexapod robots. So it's like this kind of this motion signals needs to refer to the coordination of the leg, because one leg should have its own coordinations, and then this coordination is combined become the overall robot coordinations. Okay, so in leg manipulability, so this one I will go through a little bit short. So in the performance indices, these leg manipulability, we want to see the leg limitations and the power of the foots when the leg is moved. Okay, so we want to see the point of the force on each foot. So then we can determine the limitation of the leg motions. Okay, so in the leg manipulability, the manipulability ellipsoid will be used. These properties will be used to determine the performance from the Euclidean norm. Okay, so the performance that we want to look is the how well the which area is the considered as the well motion for the foots, and which one is the very slow motion for the foots, and where is the which part is the highest power for the foods. Okay, okay, as you can see here, this is example for the four degree of freedoms of the legs. uh, did the from the ellipsoid analysis, so we can get the delimitation for the upper left, upper right, and lower left and lower right, bottom, and also where is the sense the center, which is the most optimum area of the foods. Okay, for as you can see here is the very optimum is the home, which is the initial position of the foods. Okay, so this power of the ME can be optimized actually, uh, can be optimized to be more oval than the previous determination, so that the power is bigger, because this oval is getting rounding, it, makes the most makes the food getting more power in terms of force. Okay. All right. So as you can see here, from the analysis, we can determine the sufficient motion for the sufficient motion for the foods, and uh, a lake as a general, because if you understand the kinematics, the food is any factors of the lake. So what's happened to the lake is related to the state of the joint. Okay, so um, here I want to say that this analysis is to determine the sufficient motion of the area, because uh, we want to have a very good and a very safe motion for the lakes, because as you can see there, they have a lake motion range there, which is the lake can be moved at that surface. Okay, but in the real implementation, in the real practical motion, we cannot apply like the blue surface there, because they may collict between the link, or damage the motors, or maybe performing the unstable walking. Okay, and uncontrollable walking. So here is actually we would like to create the saturation of the leg motions, so that we can control, we can optimize our walking, and the walking can be done, can be performed in stable. Okay, uh, in in other situation, we also can optimize the energy, because if we over limits the leg motion, it may consume a lot of energy, because the actuator trying too hard when the leg is stuck. So statically stable is simple, because the COG or the COM, the COM can be need to ensure that the COM are surrounding the support polygon area, as you can see in the figure. Okay. Uh, uh, but for the case how like a quadrop is in the middle between the dynamical stable and statically stable, because the four legs, uh, because this kind of leg robots has a potential that the COM outside the support polygon, as you can see in the this figure. Okay, so the more the more legs apply, or the more legs designed for the leg robot, so the more high possibility of the center of mass uh, inside the support polygon, because when the COM inside the support polygon, it can guarantee the robot is stable and avoiding the overturning. Okay, that's why the bipedal is easy to overturning, and also the quadrop robots. Okay, so the dynamically stable robots. So dynamically stable robot is where the element that the researchers or inventor focus is on the ZMP, the zero moment point, because the support polygon of this robot is a one single line, so that keep changing dynamically. Okay, so especially this line is very fast, and very fast in terms of existing, and in terms of eliminating, because uh, that's why um, bipedal robot needs more speed and need to perform very fast motion of walking. If not, they will be easily overturning. Okay. The other approach that researcher trying to do is the increase the size of the foot. So by increases the size of the foot of the bipedal robots, so easy that this robot to create the support polygon line. Okay, and the posture is controllable. Okay, so another part of the leg robot control structure is a gait pattern. Okay, so the gait pattern. So the researchers or the inventors need to understand which pattern is suitable for the certain leg robot. Depends on the number of the number of the leg of the robots and the type of the legs that use. Okay, example for the one leg robot. Okay, for this Disney research Pittsburgh outcomes, it shows that one leg robot have no choice of pattern unless performing the hopping and bouncing kind of locomotions, because these kind of robot don't have couples to be transients if compared to bipedal robots. Okay, so like a bipedal robots, the stability is depending on the ZMP, and the transient is very fast, and this kind of robots needs a very good posture control. Okay, because the response because of its dynamically stable, so makes these robots needs a very fast response and positioning on its legs to perform a very fast transient motions between the legs. So okay, it's different with the four legs quadruped robots, because these four legs robots have two stability, which is in between the dynamically stable and statically stable, because these kind of robot able to stand minimum up to 2 legs in on the ground. So the sequence may need a very fast response, very fast motions. Okay, but statically stable can be achieved, especially for the sprawling type of the quadrupeds, if compared to the mammal type or a sliding type leg quadruped. Okay, another multi-leg robot that widely designed and used is a 6 legs robot. So 6 leg robots is the one of the most stable robots, which is using 6 legs as a driven element. So in these robots have not so much problem in the overturning situations, because the minimum leg are 3 on the ground, so it can create a very good support polygon, which is triangular. Okay, and the fastest gait pattern that can be performed by this robot is a tripod gait pattern. Okay, because the tripod gate pattern performing a very minimum number of leg sequence at a time. And but the case for these legs is that this leg required a lot of actuators in its designs, and also this leg required a lot of energy because of its actuators and control. Okay. Another thing in the leg robot is in the hex support robot is the factor of the shape of the robot's body, because in hex support robot, they able to change the shape of the body, like a hexagon shape, a round shape, and trapezium shape. Okay, so all these shape playing a main factor in the movement of the hex support robot, like hexagon and round shape intends to have a circular movement if compared to the trapezium shape that intends more to the frontal and sagittal move in its design. Okay, so the control will depends on this mechanism, and the selection of the gate pattern also depends on this design shape. Okay, so let's take a look on the trends and the commercialization potential for this kind of mobile robots. Okay, actually, the leg robot is fall into the mobile robotics markets, which is are getting increased by years, according to the interest on the customers regarding its special features, and also the advantage of these robots in surpassing all terrains. Okay, so let's say for the defense, also interested in having such a dog type of robots, and agriculture is like interested in their multi-leg robots, maybe archaeology also, as well as the deep sea for the seabed explorations in the oil and gas industries. Okay, so according to the source here, it seems that the mobile robot is increasing like the others robot, but quite slowly if compared to the articulated cylindrical and SCARA and Cartesian and all that. Okay, but however, they have some increasing in the robotics, in the mobile robot markets, uh, uh, in the US. Okay, from the 2014 to 2025. Okay, so this is an example where the leg robots has been marketed and commercialized. For example, by Boston Dynamics has quite pushed a lot on the Spot Mini. So Mark Ribert strongly promoted last year's regarding this market, which is expected to be becoming demanding on this 2020 and above. Same to the agility robotics, that's confidence with the KC. The bipedal can assist a lot of things with humans, especially for the rehabilitations, and also for the postal process, for example. So a lot of things can be manipulated for this kind of robots. Okay. As for the summary, so in the leg robot is actually to design the leg robots needs to very careful in the overall design, because it will lead to the technical feasibilities and the performance that involve the target applications, um, number of legs, because number of legs will involve the stability criterion, and the lake design mechanism also involving the actuator organization, where these all these are related to the flexibility and maneuverabilities and of course the energy of the lakes. And we also needs to think about the efficiencies of the overall energy consumption of the robots, so that we can have a less bulky design. Okay, and of course, after we have a very stable hardware systems, we need to have a very good control strategies that may involve the perceptions on and the implementation of AI, and this will give impact to the outcome of the design, to create a very good lake robots, because when it comes to commercializations, um, uh, we need a very durable systems, and other than we would like to tackle the social needs, I mean the society needs, and also, and of course, the most important is the safety, because all these things are related to the target applications that we want to achieve. Okay, all right, so I think that's all for today. Thank you very much for listening my speech, and I hope this information will help some of you out there, especially who are in this field and study and research in this field. Okay, so before that, I would like to promote this one of my book with my former supervisors and others lab mates. Actually, we publish our works regarding my supervisor's robots. It is a hydraulic actuated and support robots, and names as a Comet 4. So inside there, we discuss about the preliminary design, the control systems, and fabrications, and as well as the vision systems for these robots. Okay, okay. Thank you very much, and again, thank you very much to MACE Malaysia, and Assalamualaikum.